Okay, yesterday we talked about how we can take square roots and products and break them apart and simplify these radical expressions, even expressions with variables. Because there will be times in geometry that you're not going to give a decimal, you're going to give the exact answer. So yesterday we talked about products. Today we're going to talk about dividing. Okay. So this is the quotient property. Of square roots. Okay. So this is where, when we have the square root of a over b equals the square root of a over the square root of b. I know, what a surprise. The big thing here that we will want to remember is that a needs to be bigger than or equal to 0. It cannot be negative. But what number can we not divide by? Never. Can we divide by 0? So then b has to be bigger than 0. Okay? But it cannot be equal to. Now, one of the other things that one of the things when it comes to dividing, we do not like square roots in the bottom of our answers. Okay? So this will introduce a new concept called rationalizing the denominator. Okay, so let's say we have the expression the square root of a over the square root of b. Okay. In order to rationalize the denominator, let me ask you this question. How can we get rid of a square root? What would undo a square root? What power? A squared. So the way that we can create a squared in the bottom is by multiplying the bottom by itself. Now, when you multiply the bottom, we need to keep things balanced. So you're not just going to multiply the bottom. Where else are you going to multiply? Hello. Hello. Wonderful. Wonderful.
Wow. From today to yesterday.
Huh?
$94.50. Wow.
If only the seniors were here.
Yeah, even without seniors, still.
Yeah.
Only one senior paid.
Why are the
Senior paid.
So.
They're like going on a camping thing.
Did you say your brother was going to go?
He was gonna go because like all of his classes he had seniors with, so like all of his classes are not even good.
Not true. We're doing new stuff today in trigonometry. Too bad for those 5 seniors that are going to be gone. So, but they'll be fine. We get to record a video for them. So, and they will get it. They'll get the team's message this afternoon. Here's what you missed in class today. So, Claire moved because she couldn't see from the back. So this is her new seat. And sorry, this is a total distraction.
I like your shirt.
Thank you. It is more or less true.
What does it say?
I'd rather be drinking coffee and reading a book.
I'd rather
Bacon.
How did you know?
Because I'm constantly reminded that I have not yet brought in bacon for Piper Elrod.
Oh, I forgot about
You
that.
haven't brought in bacon yet?
The last high school, bring in like,
The last.
really nice.
Bring in a George Foreman.
Don't
grill.
give me any ideas.
Bring in a George Foreman grill, we can start grilling it.
Don't make me change my mind.
You can wake up to the smell of
Okay.
sizzling bacon.
Lovely, lovely. Okay, okay. So for those who just joined us, we are talking about dividing expressions with a square root. Surprise, you put the square root on top and the square root on the bottom. And you don't want A to be negative, but then you can't have B being 0. The other thing that we don't like is square roots in the denominator, which introduces a new concept called rationalizing the denominator. We were just sharing how in order to get rid of a square root, you have to square. So when you rationalize the denominator, you multiply the denominator by itself. Now, do you think that we'll just multiply the denominator by itself? Or do you think we'll have to do something else? What do you think that something else would be? Oh. Yes, we have to multiply the numerator by the denominator. Because just like in an equation, when you do something to one side, you have to do something to the other. Here, when you do something to the bottom of the fraction, you have to do something to the top. So you multiply the numerator by the denominator. So what happens here is that this creates the square root of A times the square root of B over the square root of B squared. Okay? It creates that squared expression so that the squared and the square root will cancel each other out. Okay? You will have to do this anytime you do not have a perfect square in the denominator. Because if you just have like the square root of 4 or 9 or 16, that's going to come out to an integer. But if you've got like a 3 or a 5 or a 6 or 7, you'll need to rationalize the denominator.
You have to like show that.
You won't have to show this part, but I want us to understand that the square root of b times the square root of b is the square root of b squared, and that's how we can cancel it out. Yep. So. Okay. Oh, coffee. I love coffee. Light Rail is carrying a new coffee that's out of Colorado. They support other nonprofits, and it's actually cheaper than the Light Rail coffee that they were selling. So this one is Honduras. It's great stuff. Okay. And today's sponsor, Yeti.
Dang, we got sponsored by Yeti.
Yeti.
Good.
With their $200 $200 ice coolers.
And they're Yeti balls. You guys have one of those. They have fingers. Don't you have two? You guys have one of the dog bowls? No, they have two that they put their dogs in.
Example 2. Example 2. Simplify each expression. Okay. We are going to do 2 of these, maybe 3. Let's start out with some numbers. Square root of 2 over the square root of 27. Okay. So, the first step that we can do when solving these is use the product property. Always looking to break things up is always a good idea. So, can we break 2 up into a perfect square and a not perfect square? No. Can we break 27 into a perfect square and a not perfect square? What is that? And what? 9 and 3. Good. Now, what is the square root of 9? This 3. Good. Okay. Good. Now, the next thing we can do is rationalize the denominator. Because this is pretty simplified already, but we can make it simpler. 2. Rationalize. Now, here is something that is going to be really important. When you rationalize a denominator, you only need to multiply it by the square root part of the denominator, just like up here. Okay? Just like up here. So, if we multiply this, we will multiply it by the square root of 3. Square root of 3. Okay. So here, we will get the square root of 6. Now, the square root of 3 times the square root of 3 is 3. What's 3? So then what is 3 times 3? It is 9. Good. So here is our answer. Square root of 6 over 9. Now, why doesn't everyone take out their calculator? Now, I know that this isn't everyone, but for those who don't have the calculator that looks like this, your work to check these answers is going to be a little more tedious because it takes a little bit longer to type it in. But the great thing about these kinds of problems is we can check our answers using the calculator. So, the square root of 2 divided by the square root of 27 gives me 0.272165527. And then if I type in the square root of 6 over 9, oh, I get the same answer. So it's always a good idea with these numerical ones to type in and check your problems. Okay? Are there any questions in this first part? Yeah. Yep. So the 9 comes from the 3 times the square root of 3 squared. So the square roots cancel out, so it's just 3 times 3. Yep. That's what this step is, right here. The square root is canceled with the square. Remember, the absolute value are where you've got the 2 bars. Yep. We did see those yesterday. But, yeah. Okay. Let's do another one. A, B. Let's do the square root of 6 over the square root of 10. Now, this problem is different because you cannot break up 10 into a perfect square and a not perfect square like part A. So when we do this, so when we see these kinds of problems where there are not perfect squares, you will need to, in step 1, you will have to start with the rationalization. Okay? So, what am I going to multiply this by? Yes, square root of 10. Square root of 10 over square root of 10. Now here's something worth sharing. We could have also done that in part A. Okay? We could have multiplied at the beginning the square root of 27 and then simplified. We would have broken up the 27 on top with the 9 and the 3. We would have gotten the same answer. Okay? This equals the square root of 60 over 10. Okay? Now, using our calculator, we should check to see what perfect square goes into 60. So maybe 60 divided by 4. Look at that. That works. So, step 2, the product property. The reason I know I'm going to stop there and not try like 9 or 16 is because 15 I cannot break up anymore. Okay? So, it's going to be the square root of 4, square root of 15 over 10. So this is 2 square root of 15 over 10. So this is the same thing as the square root of the square root of 15 over 5. Okay, because 2/10 is the same thing as 1/5. Okay. Are there any questions? All right, let's do a couple with variables. A, B, C. It's like, ooh, donc, toi. That's 1, 2, 3 in French. All right. Square root of 3n over the square root of 8. What is all this bobbing of the heads? Oh, great song, great song. There are worse ones to get stuck in your head. So
there were so many good Disney songs like this.
nice.
Good job, Paul. Good job. Good job.
Round of applause
Oh, it was very good last night.
to everyone who participated last night.
I didn't have Steve knows it sitting in the back. I know.
I saw you.
I know.
And was it that full?
What? Yeah, it was full. It was full.
Oh, nice.
I mean, there was like some seats open on the left, but that's where all those people were.
There were people sitting in seats?
No.
Mind blowing.
Kind of like what normal people do.
Yes. Okay. Let's do this next one. Square root of 3n over the square root of 8. Now, let's go ahead and use the same process that we used in part B. So let's rationalize first, okay? So, what are we going to multiply the numerator and the denominator by? Square root of 8. All right. So, this is the square root of 24 n over 8. Okay? Now, one thing to remember is we are trying to simplify these as far as we can go. Okay? So, now the product rule. Product property. What two numbers where one is a perfect square multiplied to 24? 6 and 4. 4, 6, n over 8. Square root of 4 is 2 times square root of 6n over 8. So this is the same thing as the square root of 6n over 4. Okay? Chapter 10. Chapter 10. Good stuff. Good stuff. Okay. Let's do one more. A, B, and then C and D. Let's do the square root of 68 AC cubed over the square root of 27A squared. Okay. Okay. With such large numbers, I would never choose to rationalize first. Okay? Let's break these up. Okay? So let's use the product rule. Product property. Okay? Now, 68 can be divided into 4. It is 4 and 17. Okay. A will stay with the 17, and so will a C. But we can do the square root of C squared. Okay? Over. We should see the square root of 9, square root of 3, square root of A squared. Oh, the A is right there on top. Okay. All right. So, when we break it apart, let's go ahead and simplify it. Some of these parts. So here will be 2C. Square root of 17AC. What will be around the C since it's gone from even to odd? What's going to surround the C? Absolute values. Okay. Over 3 absolute value of A, square root of 3. So once we do the product property and we break everything apart, we then will rationalize. So what are we multiplying the top and the bottom by? Square root of 3. What is 17? Can someone do 17 times 3? 51. So our answer will be 2 absolute value of C square root of 51AC over, what is 3 times 3? 9. 9 absolute value of A. Okay. So your homework, that's really interesting. Huh. This is really interesting. Why would they even do that? Okay. Huh. Yeah. Allergies. Okay, your homework. I gave you 1 through 9 yesterday. Your homework today is going to be 10. 37 and 40 through 42. And it's page 10 is 631. The rest are on 632. When you look at 40 and 42, you're multiplying two fractions with radicals. you can just combine the numerators, combine the denominators. Because when you multiply fractions, that's all you have to do, okay? The bell is about to ring. Yes.
On the last one you did,
Yes.
how come on the bottom you did it times the square?
Here?
Yeah.
Because that was the square root that was in the denominator that needed to be rationalized.
And then, wait, so did it turn into square root of 9 and then
Yes.
3, and then you multiplied the 3 with 3
Yes. Yep. 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 So we will go over this homework first thing Monday.